My name is Dana.
I'm Benny Lee Wei Kang.
Mr. Nusia Mulyadi.
My name is Wan Ahmad Fazli bin Muhammad Azmi.
Good morning, I'm Benny Lee Wei Kang from Arcade 93. Today our group 12, have to present our group project. Air and water monitor system. A group background is we all know that nowadays the environment pollution become more critical. Problem is include all countries in the world, including Malaysia. In Malaysia, the landfill management are small scale operation. This causes that the waste is increasing and cannot dispose legally. So most of the people choose to dispose them illegally, like throwing them to the river or burn them. So the objective come from the problem is to design air and water monitor system based on Arduino, capable of monitoring the air and water quality. Application is also designed for the user to monitor the system and notify them when the pollution level is become high. Scope of the system is to produce a progressive and effective system who can observe air and water quality, and the prototype and application is designed for this system. Now I pass to Tanu for the methodology. Thank you.
Mr. Nusia Mulyadi, and I'm from RK53. On behalf of my part, I would like to continue with design complexity. We have proposed air and water quality monitoring system to the environment. This project is mainly shows the parameter of air and water. As we can see here, the proposed block diagram of the system shows sensors used as gas sensor MQ2, MQ3 and MQ135, temperature sensor DST11, turbidity sensor, water temperature sensor and ultrasonic sensor. Input data from all the sensors will be processed by Arduino and produces output signals. The data also will be uploaded on ThingSpeak by using connection of Wi-Fi ESP8266. This data also then sent to Android app which we have created before used MIT App Inventor as a term of the display output of sensors in graph form to the users. Next, I'm going to discuss about design flow and process. This is our flow chart of the system. The system starts to initialize when there has connection, Arduino and Wi-Fi network. If there has no connection, then it will be end process. The Arduino will read the data from sensors and sends it to the ThingSpeak to store as an graph form. Then we have created Android app and viewers can interact or start view all the results in the form of graph in the Android app. There has two options where user can also choose exit or continue. If user choose continue, then it will go to the main page user interact with Android app. And if they decided to exit, then can choose exit to leave the process and end the application.
Thank you to Tanu. My name is Dana. I'm going to present the hardware and software part, which is the software part. It will be in ThingSpeak and X. Okay, so the first one will be DHT.
MQ3 is to use to measure alcohol and benzene. It is a gas sensor. MQ135 is to measure ammonia. MQ2 is to measure LPG, carbon monoxide and also smoke. This is the water temperature sensor. It is the water resistor. The dipping in the water, and this is the turbidity sensor. It is used to see whether the water is clear or not. This is the ultrasonic sensor. It is used to measure the water level. And we use a microcontroller Arduino Uno. And the last one, we use ESP8266 as a Wi-Fi connection.
To know whether it uploaded into ThingSpeak already or not, you can see the value display and the Wi-Fi connection is connected. This is our ThinkSpeak. We store all data from the sensor. Okay, let's go to our apps, which at the front page is display air and water control system.
For water quality view, and this is the feedback, which right now it's in normal condition. So we turn back to front page and we go to graph button. Okay. Okay, right now it's display. Okay, right now it's display water level graph and air temperature. And next, humidity level and alcohol level graph. The next one, and the last one is display smoke level graph and turbidity graph. So we're going back to main menu, and that's it. We just exit.
Okay, let's see ultrasonic sensor do. Okay, this is the normal level, which 50% level. So let's start for experiment. This is water. So this is the difference after pouring the water. So our water level increased to 75%. To detect smoke, we use MQ135 to detect the smoke. This is the normal graph. This is the smoke. Let's see what's happened. The graph increased above 350. This is the graph for alcohol value. And graph is various because of Wi-Fi connectivity. If we put the alcohol into this and we put it at MQ3 sensor, graph is increased to 400 and above. This is the water temperature graph, which display a normal value. Let's see what's happened if we put in hot water. Here's a result. It's increased positive value, and it's false because of the Wi-Fi connectivity. As you can see, this is turbidity graph, which means the water referred to normal water. And let's see what's happened if we dip it in tea. From the graph, we can see the graph, which means the water is cloudy.
Assalamualaikum. Hello, my name is Wan Ahmad Fadli bin Wan Muhammad Azmi. I am from RK20 Computer Engineering. Health and safety consideration. For aspect of health, this project design impact of health for humans because they can monitor the quality of air and water without affecting their life. Next, for safety purpose, all the components project designs follow all the safety guidelines, and this project is conducted in a very safety conditions as the total power needed in this project only 5 volt to operate. Environmental consideration. Firstly, the project design has alert system, whereas the Android application will show all the real-time data to let the user notice if the quality of air and water is in good or bad condition. Then it is environment friendly. This project design are not causing any pollutions, especially to air and water quality. This project also shows statistics through Android application to monitor the environment surroundings. Cultural and benefit to society. We have ThinkSpeak application and MIT App Inventor. ThinkSpeak application is benefit to society because the use of ThinkSpeak application is to collect, analyze and process the data input in analytical purpose. It then can be used for improvement of quality of air and water for the environment. For MIT App Inventor, it is easy to use and give the mobility to the users to improve their quality of life. Time can be saved and less cost for maintenance is the impact of using this application.
Now we proceed to the project management and costing. From the Gantt chart, we can see that we try to contribute to all sections for the report and also the circuit designing and the Arduino designing. Except for sometimes because of the time schedule or the capability, we cannot contribute inside that section. The table is show the component that we use and the price of them. The total price is around 124.74 cents. The next table is another set of components which is and the cost. This price is more higher, about 4 times or 5 times compared to ours. So we can conclude that our component is very low price and can be used by most of the people. Thank you for listening.